Hello and welcome to Physics Phenomena. I'm your host, Bridget, and today we'll be discussing wave behaviors. What type of wave behaviors? Interference. Let's talk about that. So, interference is the interaction between two or more waves. You know what's really cool about waves? They can exist in the same medium at the same time, unlike particles. A great example of this is destructive and constructive interference.
Hello, I am your other host, Ayana, and I will be discussing about the definitions of constructive interference and destructive interference. So here it is. Constructive interference is when you have the maximum displacement of two waves entering the same medium in different directions. So what happens is, if you have a slinky, for example, and you have a wave coming from this side and a wave coming from this side, they meet in the middle, they create a huge wave, so that's where you have maximum displacement.
What you are watching right now is constructive interference. There are two wave pulses that exist in the same place at the same time. They are both pointed in the same direction, but are traveling in opposite directions. When the waves clash together, it results in a wave that has an amplitude larger than any of the individual waves. Where the two waves join is called the antinote, which is the point of largest amplitude when two wave pulses meet of two superimposed waves. The two pulses pass through each other without changing their shapes or sizes. Now let's switch the style up a little bit and discuss destructive interference.
We're going to talk about destructive interference, which is the exact opposite of constructive interference. Destructive interference is the superposition of waves where they have opposite but equal amplitudes. Now let me tone it down a bit. Let me speak English. Destructive interference is what happens when, let's say you take a slinky for instance. You have a wave going down and a wave going up. When those two meet in the middle, their amplitudes cancel out, since you have a negative and a positive, and the displacement is zero. Now, let's show the videos.
This is an example of a destructive interference. As you can see, there are two wave pulses that exist in the same place at the same time, which is quite similar to constructive interference. However, there are a few differences between the two. With destructive interference, the two wave pulses are not only traveling in opposite directions, but they are also both pointing in opposite directions, where one wave is erect and the other is inverted. When the waves meet and are in the same location, they are at the node, where the medium remains undisturbed. At this point, the displacement is zero. The pulses continue to move and eventually return their original form. As in constructive interference, the waves pass through each other unchanged. Now let's head back to Bridget.
For watching. Tune in next time to Physics Phenomenon. See you later.